Good morning, everyone. Imagine this. What if every decision you've ever made, every choice, every path not taken, exists somewhere else? Somewhere out there, another version of you might have taken that job offer, moved to a different city, or even pursued an entirely different life. Sounds like science fiction, right? Well, today we're diving into one of the most mind-bending ideas in modern science, the concept of the multiverse. Right. The multiverse refers to the hypothetical existence of multiple, possibly infinite universes that coexist alongside our own. These universes could be vastly different from ours, with their own laws of physics, histories, and even versions of ourselves. While it sounds like something straight out of a sci-fi movie, the idea has deep roots in both ancient philosophy and cutting-edge science. But why should we care about the multiverse? Isn't it just a fun thought experiment? Actually, no. The multiverse isn't just a fantasy, it's a serious scientific hypothesis with profound implications for how we understand reality. Recent breakthroughs in quantum mechanics, cosmology, and string theory have reignited interest in this idea, making it more relevant than ever before. So buckle up, because over the next hour or so, we're going to explore the origins of the multiverse theory, examine the latest evidence supporting it, discuss its philosophical and technological implications, and address some of the controversies surrounding it. By the end, I hope you'll see the multiverse not as a distant abstraction, but as a fascinating lens through which we can view our place in the cosmos. The idea of multiple worlds isn't new. In fact, it dates back thousands of years. Ancient Hindu texts describe lokas, or planes of existence, each with its own gods, beings, and rules. Similarly, Plato's famous allegory of the cave suggests that what we perceive as reality might just be shadows cast by a higher truth. These early ideas planted the seeds for modern interpretations of alternate realities. Fast forward to the 20th century, when physics began to take center stage. One of the first major contributions came from Hugh Everett III, a physicist who proposed the many worlds interpretation of quantum mechanics in the 1950s. Here's how it works. At the quantum level, particles exist in multiple states simultaneously, a phenomenon called superposition. When we observe a particle, it appears to choose one state. But according to Everett, the universe doesn't collapse into a single outcome. Instead, it splits into multiple branches, each representing a possible result. To put it simply, imagine flipping a coin. Instead of landing on heads or tails, two separate universes are created. One where it lands heads and another where it lands tails. This process happens constantly, leading to an unimaginable number of parallel universes. Now let's zoom out to the largest scales of the universe. The Big Bang Theory tells us that our universe began as a singularity, an infinitely dense point that expanded rapidly. But what caused that expansion? Enter the cosmic inflation, a theory developed by Alan Guth in the 1980s. According to inflation, the universe underwent an exponential growth spurt in its earliest moments. And here's the kicker. Some versions of inflation suggest that this process never truly stopped. New bubbles of space-time are constantly forming, each with its own unique properties. This gives rise to the idea of a multiverse of bubbles, where our universe is just one among countless others. Andre Linde took this a step further with his theory of eternal inflation, proposing that these bubble universes are born continuously, creating an endless sea of possibilities. Let's dive deeper into quantum mechanics, because it's here that the multiverse finds some of its strongest support. Remember superposition, the idea that particles can exist in multiple states at once? Well, experiments like the double-slit experiment have shown that particles behave differently depending on whether they're being observed. This strange behavior led physicists to wonder, what happens to the other potential outcomes? Do they just disappear? Enter the many worlds interpretation again. Instead of disappearing, those other outcomes branch off into separate universes. So every time a quantum event occurs, the universe splits into multiple realities. It's a radical idea, but one that elegantly explains some of the quirks of quantum mechanics. Now let's look at the bigger picture. One of the most exciting areas of research involves the cosmic microwave background radiation, CMB, the faint glow left over from the Big Bang. Scientists have detected anomalies in the CMB that don't quite fit our current models of the universe. Some researchers interpret these anomalies as signs of collisions between our universe and others during their formation. Think of them as bruises left behind after a cosmic bump. While this evidence is still controversial, it sparked intense debate and further investigation. If confirmed, it would provide some of the first direct clues about the existence of other universes. Another intriguing possibility comes from string theory, which posits that the fundamental building blocks of the universe aren't particles, but tiny, vibrating strings. To make sense of string theory mathematically, physicists propose the existence of extra dimensions beyond the familiar three spatial dimensions and one time dimension. In this framework, our universe might exist on a brane, a kind of membrane floating in a higher dimensional space. Other branes could host entirely separate universes, occasionally colliding and giving birth to new ones. This idea, known as the Shaner-e-brain world scenario, adds another layer to the multiverse puzzle. Finally, let's talk about black holes and wormholes. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. Some theories suggest that black holes might serve as portals to other universes. Similarly, wormholes, Esherum or Einstein-Rosen bridges, are theoretical shortcuts through space-time that could connect distant parts of the multiverse. While we haven't found definitive proof yet, these ideas continue to inspire both scientists and science fiction writers alike. The multiverse raises some profound philosophical questions. For example, if infinite versions of you exist, what does that mean for free will? Are your choices truly yours, or are they predetermined by the branching paths of the multiverse? And if every possible outcome exists somewhere, does that diminish the significance of our individual lives or enhance it? On the ethical front, the multiverse introduces some tricky dilemmas. If every decision creates a new universe, do we bear responsibility for the consequences in those alternate realities? Could advanced civilizations manipulate the multiverse, potentially endangering entire universes? These are questions we may need to grapple with as technology advances. Speaking of technology, the multiverse opens up some wild possibilities. Could humans someday harness wormholes to travel between universes? Might artificial intelligence simulate entire multiverses, allowing us to explore them virtually? While these ideas sound far-fetched, they highlight the boundless potential of human curiosity and ingenuity. Not everyone is convinced by the multiverse theory. Critics argue that it's inherently untestable. We can't directly observe or interact with other universes, so how can we prove they exist? Without testability, the multiverse risks becoming more of a philosophical speculation than a rigorous scientific model. There are also alternative theories that attempt to explain the same phenomena without invoking multiple universes. For instance, loop quantum gravity and the holographic principle offer different ways to understand the nature of reality. These approaches focus on rethinking the structure of space-time itself, rather than positing an infinite array of universes. It's worth noting that pop culture often oversimplifies the multiverse. Movies and TV shows portray characters hopping effortlessly between dimensions, but the reality, if it exists, is likely much more complex. Real-world physics suggests that traveling between universes, if possible at all, would involve overcoming immense challenges, such as navigating higher dimensional spaces or surviving extreme gravitational forces. To recap, we've covered a lot of ground today. We started with the ancient philosophical roots of the multiverse, explored its modern scientific foundations in quantum mechanics and cosmology, examined recent discoveries in speculative technologies, and addressed some of the criticisms and controversies surrounding the theory. Whether the multiverse turns out to be real or remains a tantalizing hypothesis, it challenges us to rethink everything we know about reality. It invites us to dream bigger, question deeper, and embrace the wonder of the unknown. After all, the quest to understand the universe, and perhaps the multiverse, is one of humanity's greatest adventures. I encourage you to stay curious and keep exploring the frontiers of science. If you're interested in learning more, I recommend books like The Hidden Reality by Brian Greene or documentaries like Parallel Worlds, Parallel Lives. Thank you for joining me on this journey through the multiverse. Before we wrap up, I'd love to hear your thoughts and answer any questions you might have. Feel free to ask anything, from clarifications on complex concepts to your own speculations about the multiverse. Let's keep the conversation going. This full script provides a comprehensive overview of the multiverse, balancing accessibility with depth. It's designed to captivate audiences of all backgrounds while leaving room for discussion and reflection. Let me know if you'd like to tweak or expand any part of it.